A register is a storage unit that can do two things. So it can change its state to a given input, and it can also maintain this state over time. So essentially it can store a particular input. So a single bit register is created just using a single flip-flop, and which can change the state of the register or the flip-flop by loading a new value into that flip-flop or register. So in this course, we'll refer to a single bit register as a bit, and then we can have to go about chaining together multiple single bit registers in parallel in order to create multi-bit registers. So if we get 8 bits, 8 individual bit registers, we can combine those together to create an 8-bit register in which we can store a single byte. So this shows us the interface. So we can see for a bit we've got an input, an output, and then we've also got this load input as well. So if load is 1, then the output at time t becomes equal to the input in the previous time step. And if the load is 0, it just stays the same. So we have to look at the implementation. So we can see the actual internal workings of a bit is actually very simple. So it's got a sequential logic circuit, the D-type flip-flop, and then it's also got a mux, which is just a combinational logic as well, what we've seen before. So if load is 0, it'll actually be this input for the mux which is selected. So you can see the output just feeds back into the mux, goes back in, and it just, this feedback loop then just maintains the state. So if load is 0, we'll not load a new value, we'll just keep going round. The output just feed back and it essentially keeps storing that same value. Now when load is a 1, this input or the mux will be selected, and then whatever value is on the input then will then be loaded into the D-type flip-flop. So it's very easy, very simple implementation. So we can see here how we can combine individual bits to create multi-bit registers. So the Hat computer has got a word size of 16 bits. So this essentially means all the registers are 16 bits wide. So in your desktop computer you might have a 32-bit machine, or most likely 64-bit machine. So the word size for those is 32 bits or 64 bits. So this means the registers inside are either 32 bits wide or 64 bits wide. But in this case, a Hat computer is 16-bit, so our registers are also 16-bit. So this means in a particular register, we can store, this is in binary, 16 zeros up to 16 ones. So in decimal, well, we assume unsigned numbers, that gives us 0 up to 65353. Or in signed numbers, we're using the 2's complement representation of the binary numbers. We'll go from minus 32,000 up to plus 32,000. And then we know in hex, we can just convert each nibble individually. So that gives us 0x 4 zeros or 0x FFF for all the ones. So each one of these nibbles corresponds to F. So that's the values we can store in a 16-bit register. And here, the behaviour is just the same, but now rather than being a single wire, if you will, our input and output, we now got this input bus. So for this case, we're building a 16-bit register. The input will be 16-bit bus, and the output will be a 16-bit bus. And again, it's the same though, in terms of the load behaviour. If you put a 0 into the load, the bits will just save, well, they just kind of keep the same values previously, and it's only when this load bit becomes a 1 that the new value on the input will be loaded into the register and appear on the output.